When managing hybrid network connectivity between AWS and on-premises infrastructure, you often lack visibility into which BGP routes AWS accepts from your routers and which routes AWS advertises back. This creates challenges when troubleshooting routing issues, verifying route propagation, or diagnosing unexpected traffic patterns. You can now view accepted and advertised routes across VIFs to see exactly which routes are exchanged between AWS and your on-premises routers for private, transit, and public virtual interfaces. You can access route details via console or API using the list virtual interface routes action to retrieve prefix, address family, AS path, community values, and installation timestamps programmatically. You can filter routes by prefix, AS path, or community to quickly identify specific routing behaviors without manually parsing configurations. You can monitor routing topology with timestamps to maintain comprehensive insight into your hybrid network, validate BGP policy configurations, and manage multi-region architectures. Testing IAM policies before deployment is necessary to prevent security gaps and overpermissive access, but validating how policies interact across organizational boundaries and understanding which specific policies cause denials has been difficult. You can now access IAM Policy Simulator directly in the IAM console where you manage identities and policies. You can test service control policies alongside identity and resource policies to validate how your organization's SCP hierarchy affects permissions. You can exclude specific policies from simulations to model what happens when you remove them. For cross-account scenarios, you can view per-policy decisions that show which identity and resource-based policies drove the outcome, with match statements reflecting only the policies that caused a denial. These capabilities help you automate policy unit testing, detect overpermissive access, and validate guardrails through the console and API. Delivering Apache Kafka data to Amazon S3 for log archival, compliance retention, replay, and ML model training typically requires self-managed connectors that become operationally complex and costly as workloads scale. You must build or source connector plugins, deploy them, scale capacity continuously, and apply security updates across your connector fleet. MSK Express now provides a capability that delivers Kafka data directly to S3 general-purpose buckets without requiring you to manage connectors. The service automatically handles scaling, retries, and backpressure to support throughput up to 10 gigabytes per second. You can reduce delivery costs by up to 60% compared to self-managed alternatives because you add this capability without provisioning additional broker egress throughput. This eliminates the infrastructure costs that connector-based pipelines incur, letting you scale to actual demand rather than provisioning for peak capacity while maintaining reliability for mission-critical workloads. Vector workloads in search operations often consume significant storage, memory, and compute resources while providing limited visibility into query performance and search quality. OpenSearch 3.7 addresses these challenges through several technical enhancements. You can compress vectors using 1-bit scalar quantization on FICE and Lucene engines, reducing storage and memory requirements while maintaining search accuracy. You can retrieve vectors faster by using doc values instead of document source, with no reindexing required. You can evaluate and improve search quality using Search Relevance Workbench, which now includes new evaluation metrics, CSV judgment uploads, and expanded hybrid search optimization. You can export top query data to Amazon S3 through Query Insights, enabling you to identify expensive queries, analyze trends over time, and receive automated query recommendations through the finished queries cache. OpenSearch 3.7 is available in all AWS regions where Amazon OpenSearch Service operates. Previously, you had to build multi-VPC architectures with additional routing hops to achieve traffic steering or workload isolation, adding complexity and operational overhead. Policy-based routing for AWS Transit Gateway solves this by extending native routing capabilities to make forwarding decisions based on multiple packet attributes rather than destination IP alone. You can now route traffic by source, destination, port, and protocol, giving you granular control over traffic flows. You associate policy tables with transit gateway attachments to enable inline traffic classification without extra infrastructure. You define ordered rules with first match wins logic that classify traffic and direct matching packets to specified route tables. You can configure PBR via console, CLI, or SDK at no extra cost beyond standard transit gateway fees. This enables use cases like steering workloads through AWS network firewall, routing traffic over direct connect or VPN paths based on packet attributes, and isolating production and development environments to limit lateral movement. When your organization grows beyond 5,000 users and objects, you face the challenge of migrating to a larger directory infrastructure without disrupting existing services and connections. AWS Directory Service now enables you to upgrade your managed Microsoft AD from Standard to Enterprise Edition directly through the console, CLI, or API. You can upgrade in place without migrating to a new directory or rejoining workloads. The upgrade preserves your existing trust relationships, application integrations, and group policies automatically. Your DNS configuration and connected AWS workloads remain unchanged throughout the process. This allows you to scale from 5,000 to 500,000 objects without service interruption or reconfiguration of your directory-dependent resources.